Hello everyone and welcome to the second webinar of the PAT course 2025. For those of you who are new, my name is Kat, my pronouns are she, her, and I'm the Access Officer for the Department of Physics. That means that I run all of our sessions very much like this one today for people who are interested in studying physics. Welcome back to those of you who were here last week. You already knew all of that. Today's session is being recorded. I will make it available to you tomorrow along with any links that we use tonight. A quick reminder of the housekeeping rules for those of you joining us today. You already have access to the chat. Please use it to share any thoughts and feelings as we go. Keep it polite and kind. Don't share any personal details. A bit later on, I will also switch on the Q&A. You'll be able to use it to ask any questions relating to the solutions currently being presented. If at any point you're feeling unsafe or concerned, you can always contact our safeguarding lead or message me directly using hosts and panelists. But without any further ado, let's jump in. So the PAT is the physics admissions test. It is the required test and it must be sat by all candidates for physics, physics and philosophy, engineering and materials science. Your score on the PAT forms part of the information which admissions tutors use to decide who is shortlisted for interview. To sit the PAT, you must register as a candidate. Your school will not arrange this for you. The PAT this year will be on screen and entirely multiple choice, just as it was in 2024. We've worked hard to make sure that we can gain as much information as possible from this format, so the answers aren't just 1 mark or 0, some questions are worth more marks. But the syllabus is unchanged and it's been the same since 2018. So all of the questions that we look at, whether they are long form or short form, are absolutely relevant to you. The online test includes an on-screen calculator and it looks just like a regular calculator, works in the same way. There's a practice of the online test format and the calculator, and I shared that in last Thursday's email and I'll share again tomorrow and on screen in just a few minutes. This webinar is part of the PAT preparation course, which we run on behalf of all subjects who require the PAT. And the Preparing for the PAT course is a set of 8 webinars, along with problem sets, summer assignments and videos. And we hope to provide you with all the information that you need to take the PAT, to help prepare for the PAT, and to be confident going into interviews if you are shortlisted. The timetable on screen at the moment is part of the timetable which is at the bottom of every PAT email. I always highlight it so you can follow our progress. And in each session, I'll fill you in on any updates and news. Today is our first solutions webinar and you can see us highlighted in yellow on the slide. All of the information about the course and all of the course materials are on the course materials page, and I link to this in every email. At the moment, the page looks something like this. The physics problem solving introduction right at the top has some general hints and tips, and Rachel took you through those last week. You can access the recording of that webinar at any time via the links at the bottom of the page. At the moment, you've got last week's webinar, the recording, the problems used and the problems asked for tonight. I'll share some links a bit later if anyone needs anything. Finally, before we get started, this is my quick reminder that all of the information about the PAT that both you and your school need can be found at this page. I share that link in every Thursday emails and you're always able to find it. It's the most up-to-date page and the one to check first for any information that you need. It also has a really useful FAQ page that has pretty much everything that you can think of. Key facts to finish up before we start. This year, all tests will be sat at Pearson Test Centres. There are venues in almost every country around the world, and when you register for a test, you can select a centre which is most convenient to you. For some people, this might involve some travel, but hopefully not too much. This arrangement is exactly the same as for tests like the LNAT and the BMAT and the Cambridge admissions test, so hopefully it won't be too new to you. The PAT is completely free to register for and to sit. If you are eligible for any access arrangements such as extra time, you can apply for them when you register. Registration opens today, as you can see on screen, and is open until the 19th of September. Booking a test slot opens a little bit later. So once you've registered, there's then a separate come book a test slot with us. That opens on the 18th of August, maybe the 19th, and is open until the 26th of September. We recommend you register for your test and register for the PAT itself nice and early, particularly if you have access arrangements, so that we can make sure we've got everything that you need in place. The PAT itself is on the 22nd and 23rd of October. Please don't use the chat for questions. If you have questions, wait until the Q&A is open. I mentioned earlier that the test format was new last year, but the questions were and are again really similar to those in the past papers, and our syllabus is unchanged. That practice paper where you can access the calculator and get used to the format can be found at the link on screen at the moment, and I will share that in the chat and by email tomorrow. Finally, we offer some targeted additional support sessions. Please check if you're eligible, and you can apply via the link that's on screen, which again, I'll pop in the chat in just a sec. Applications close tonight at midnight UK time. They've been open for a little while now. Please do check the eligibility criteria before you apply so that you're not wasting your time putting in an application. But if you are eligible, get your application in. That is my quick PAT introduction and update. I hope it was helpful. I'll take questions at the end of today's session if we've got time, and I'll try to make time whenever we do have extra time. For now, I'm going to stop screen sharing. I'm going to hand over to Liam for our first PAT study session, share some links in the chat, and see if I can fix the problem that we had with YouTube. And I believe, Liam, hopefully that will have given you enough notice. Lovely to meet you. I'm going to hand straight over to you. Anything that you mention, I'll try and quickly pop into the chat as we go, and I will open up the Q&A in case anyone has questions about your solutions as we go.
Okay, right, I'll get started quickly then. I'm going to go through questions 1 and 2. So just share my screen here. That's not the right screen, hold on. So what's everyone seeing now? There we go. So that looks like the solutions. Okay. So in our first question, we've got a ball and it's bouncing on a hard surface and it loses a quarter of its kinetic energy with every bounce. And we've been asked to find out after how many bounces it will bounce no higher than 25 centimeters.
Oh, we've had someone saying they can only see a blank screen. Let's see if anyone else comes up and says that that's a problem.
Can you see it?
Okay, I can see it, and everyone else is saying they can see it as well. So it must just have been a bit of a one-off.
If it's fixed now, should I keep going?
I think we're okay. For those of you who aren't able to see, hopefully that will kind of spring back to life for you in just a sec, because there's not much we can do from our side, unfortunately.
Okay. So the important thing to know is that apart from when the ball bounces, energy is always conserved. So at the top of the bounce, all the energy is going to be potential energy, and at the bottom, it's going to all be in our kinetic energy. So in order to work out how the energy changes, we don't actually have to think about the kinetic energy. All we need to think about is the maximum potential energy at the top of the arc. So we know this is going to be mgh, and we know that the original h, which I've called h naught in this solution, so before any bounces, is 1 meter. And we know that after a bounce, if a quarter of the energy is lost, 3/4 is left. So we know that after one bounce, we're going to have 3/4 of the energy, and because energy is proportional to height, it means that the first height reached after this will also be 3/4 of the original height. So when we do this, we get the fraction hn over h naught equals 3/4 to the power of n, since hn is the height after n bounces. And then all we need to do, since we've been given that hn over h naught must be less than or equal to a quarter, is we just create this inequality down here, and we solve it using our usual logarithmic tricks. And when we put the numbers in, we get that is after the 5th bounce. It won't bounce any higher than 25 centimeters. So yeah, are there any questions about this problem? Anything more specific about the maths? Because I have just glazed over it and talked about the process.
Nothing coming through in the Q&A, so think we're okay. We've got a few people ask, there we are. Got a few people coming through about the powers and the logs. So I think we might need a tiny bit more detail
how to
there.
solve this? Okay, so are you happy with the a quarter is less than or equal to 3/4 to the power of n?
Yeah, look, so the questions we've got
Okay.
are how did you work out the logs? How did you get 3/4 to the power of n?
Okay, so 3/4 to the power of n. So if we call E1 the energy after the first bounce, E1 is going to be 3/4 of E naught, which is what they told us because a quarter of the energy is lost. So if a quarter is lost, 3/4 is left. So if you took another bounce, another 3/4 would be lost from, and then so relative to E naught, 3/4 squared has been lost. So this process repeats, and that's where we get 3/4 to the n. And then for the logs, we just take our fraction, our 1/4 less than or equal to 3/4 to the power of n. We take log of either side, and then you may not have seen this yet, but there's just log identity, but log x to the power of y equals y log x. So that gives us n log 3/4. And then all you do is you divide by log 3/4 and put that into a calculator, and that's where you get your 4.82 from. And I would add, if you're not sure what way the sign goes, because you might be dividing by a negative and that can cause problems, it's useful to think, am I expecting it to be a greater than or less than? And since we're looking for when the height is no longer larger than 25, we suspect that the bounces is going to be greater than a certain number. So yeah, does that make it any clearer?
I think so. I'm not sure if you're able to see the questions as well.
I can see the chat. Oh yeah, ln is log base e. You could also use log base 10. It doesn't really make a difference. I just use ln. Yeah, someone said log 10 and log e doesn't make a difference. So yeah, can you please explain it? So 1/4, the 1/4 comes from the fact that we're told we want our height to be no higher than 0.25. So we've put 0.25 and divided it by original height, 1 meter. So we know that that's going to be 0.25 over 1, which is a quarter. And we want it to be less than this. So we've found our fraction for hn over h naught, and then we just put that into the equation above it, which came from us equating the energies. And reason for not using the index n-1. I think the using naught as an index was just a personal choice. I don't think it matters too much what you go for. I just prefer using naught instead of 1. I think that answers all the questions. So
Thank you so much, Liam. Yeah, I think we're okay.
slide on to the second one.
Yeah, go for
I
it.
suppose if anyone still has questions at the end, they can ask them, can't they? So I'll move on to question 2 for now.
Yeah.
Okay, perfect. So in the second question, we've got a cylinder of clay, and we want to work out what length of clay we need to make the snowman. Sorry, the snowman. And we're given the snowman is made up of one sphere of radius r and another sphere of radius 2r. Then, sorry, someone said they think I've muted myself. Can anyone else? Can everyone else hear me? Okay,
I can
I'll
hear
keep
you,
going.
yeah.
So yeah, so we've got the volume of the snowman, which is just the sum of two spheres, and then we've got the volume of the modeling clay, which is just a cylinder with radius r/2 and height h, or I labeled it height h. That wasn't explicitly given in the question. So we know that the volumes must be equal. So we write the volume of snowman equals volume of cylinder, which is this equation here. 4/3 pi r cubed for the first sphere, and then 4/3 pi times 2r cubed for the second sphere. And then here pi r/2 squared times h is the volume of our cylinder of clay. And then this is just algebra from here, rearranging it. And when you do that, you'll get 48r. There's not too much to say here. I mean, all you need to do is put the numbers in once you've got the equation on the fourth line. And yeah, this will come out. Has anyone got any questions about this problem?
My apologies, I'm answering a few other questions. A few people saying, how do you know the answer is supposed to be in terms of R?
Well, I think I just did the algebra and it was left in terms of R. I'd say you're not given any other unit of measurement. There's no explicit radius given. So if you're not given the exact radius, then you're going to leave it in that. So yeah, because you've given no numbers, you have to leave it in the terms of letters that you're provided.
Perfect. You've got a lot of thumbs up, which I think is a good sign.
Okay. All right. So yeah, I'll leave it there. If anyone wants to ask questions about these, we can go through them at the end. But I'll pass over to who's next, Kat?
Hello, Aria. Nice to see you.
Hi, can you hear me?
Yeah, I can hear you all right.
Oh, lovely. Okay, I'll share my screen and we'll carry on with the next set of questions. Hopefully everyone can see this.
I can see that absolutely perfectly. Let's wait and see if we get any questions or comments through.
Okay.
Yeah, I think we're good. Thank you for making use of the reactions, everyone. It's really helpful for us. It means we can get a quick idea of how you're all doing.
So, okay, this question is classic masonist spring. They've even given you what the time period is, and there's sort of questions about changing the setting and seeing what happens. The first one I think was quite simple because they said what happens if you take it to a different planet and you put it in 2g acceleration instead of g. Well, clearly the formula only depends on two parameters, the mass that's hanging, m, and the spring constant, k, which is a property of the spring itself. So it doesn't rely on what the acceleration due to gravity is. So that's why the time period stays exactly the same, because it's independent of g. I'll move on to the part B. So part B and C are also very classic questions where they try and create sort of series in parallel of springs, kind of like resistors. And there's, well, I guess the initial first way of looking at it, if you don't know the rule, is to consider what happens if you look at the forces specifically. So I've tried to draw sort of a force diagram to show you that force F is acting throughout. I could say tension, but T would get confused with time period. This force F is acting on the springs, two identical springs that are in series. And for each one, the spring constant is K. So you get a certain extension, X1 equals F over K. So X1 being the extension of this first one, and X2 being the extension of the second spring. And they're both equal because so the force acting on each spring is the same, and the same spring constant. So X1 and X2 are equal, and you know exactly what they are, F over K. Now the idea is to basically put a black box here and think, if you didn't know what the setup was, and we had this one spring, what would be the effective spring constant that would result in sort of a similar extension? So the force acting would be the same. This new effective spring constant would be this K prime. And the extension X, well, the extension X is just a sum of X1 and X2, both going downwards. So you can just sub in X is equal to X1 plus X2, which is equal to 2F over K. So you get this property that the effective spring constant is half the spring constant of each spring. So you can just put that into your formula for time period, and you get that the new time period is √2 times the original time period. And I sort of try to do a similar thing where now I put them in parallel, and I consider the fact that the force still must be F upwards, but now that you have two springs, you can split them equally because it's a symmetric system, F over 2, F over 2. So what you achieve is half the extension in each spring because you have half the force applied. So the next extension is half. And because the net extension is half for the same force, the effective spring constant doubles, just again using Hooke's law. So what you get is the new time period being 1 over √2 times the original time period. This is the way to do it right from scratch, but if you were doing it sort of, if you've seen it a few times, well, you can also notice that there's a parallel to sort of how resistors work in circuit. It's just that when resistors are in series, you add up the resistance. We sort of have a similar idea for springs in parallel. In part B, how have you gone from F equals K prime X to 2KX1? So basically in the first one, you have, let's say, considering the equation of motion, not the equation, the force balance. So F over 2 equals KX1, right? Because K is the same, and let's consider X1 being the left spring's extension. And on the right side also, you have F over 2 is equal to KX2, right? So clearly, again, you can see X1 is equal to X2. And you know that X1 is equal to X2 is equal to F over 2K, right? So this is sort of the overall extension. So if you had black box again, you didn't know what the spring was, you would just notice that its extension is F over 2K. So essentially what you have is you're applying a force of F onto some new spring, K prime spring constant, and extension of X1 or X2, doesn't matter, they're the same. So what you get is F over 2K, right? I'm just subbed in the value here. And if you cancel, rearrange, you get the new effective spring constant is twice. Would it be okay to have your answer in a different form, such as T equals 2 pi root? Yeah, of course, that's okay.
Could I just remind everyone, if you pop your questions in the Q&A rather than the chat, it makes it much easier for me to answer them. Thanks. Sorry, Aria, carry on.
All good. So hopefully, yeah, of course, that way of writing it also works. I think I was just trying to make it so it related to the original time period T, but as long as you have the new spring constant, you're good. So yeah, this is springs in parallels, which is resembling essentially resistors in series. So hopefully, this is it's a classic question. So if it comes up, you're familiar with it. And I'll move on to the next one, which is I think this is a classic sort of SUVAT question, something you've been doing GCSEs and A levels. You have certain initial velocity of 10 meters per second at an angle of 30 degrees horizontal. What I would recommend for any SUVAT question is to to do two things at first. First, draw a diagram, like a clearly labeled diagram, and second, define what you take as positive, because you can quite easily confuse yourself about what's up, what's down, what's positive, what's negative, and it can cause you to get the wrong value. And here we care about basically finding how long it takes for the ball to hit the beach below. So we're interested in time and along the vertical motion. So I've only considered what happens vertically. My vertical velocity is obviously 10 sine theta here, 5 meters per second. The acceleration they told you can take is 10 meters per second squared, but it's downward, so it's negative. Displacement is basically whatever height of the cliff you fall, which is obviously minus 10 because you're going downwards from your initial position. So you have SUA, you need to find T. You can use S equals UT plus half AT squared, just subbing the values. I got a quadratic. I solved the quadratic. Obviously, time cannot be negative. So the only possible solution is that it takes you 2 seconds to get to the ground. And I think that was a rather simple one. So hopefully people understood that.
Oh, we've got 1 or 2 questions sitting in the Q&A. We had a question about your specific meaning of K prime X, springs in series. In fact, I don't. Can you see the Q&A, Aria? I don't know how many screens you've got.
Oh, Q&A. Oh, there we go. Yeah. Oh, actually, I can. Sorry.
Oh,
so
perfect.
Just
saves me reading them out to you.
Oh yeah, I've been writing on my iPad, so I've got 2 screens going at once.
Perfect.
I'll just take these quickly. So what does K prime X mean? Okay. I believe you're referring to this first bit here in the middle. So I essentially said that Hooke's law is F equals Kx, right? Where F is the force applied, K is the spring constant, X is the displacement from equilibrium. So it doesn't matter what kind of system there is, this law will, in this sort of case will apply. So I said basically I have 2 springs connected together, but I'm kind of modeling them as one spring, because if I didn't know what was going on in the system, I would just pretend there's one spring. I will measure the extension I get. I know what the force I'm applying is just the same, and I essentially get what the spring constant of that one spring would be. So because I know what my total displacement is, it's x1 plus x2, that just becomes my displacement x. So x equals x plus x2. So in this case, 2x1, because we know x1 is equal to x2. And K prime is just the new spring constant of this combined spring, which is made up of 2 springs of equal spring constant K. So K prime is just the new spring constant. Hopefully that makes sense. Can you please explain why on part C it's the reciprocal of square root of 2 rather than just... So why on part C? Okay. Right, so T, the general formula for T is 2 pi root m over K, right? So we're considering our new spring constant, which is, well, we said K prime is equal to 2K, right? So what you're essentially doing is putting in 2K here, because this K just means spring constant of the spring you're considering. So T equals 2 pi, mass is the same. The new spring constant, so rather you should consider K prime, is 2K. So I've got 2 pi, a factor of root 2 out, m over K. And this just goes to root 2 pi, m over K. So the pi is outside, m over K. So so reciprocal of square root of 2 rather than just the square root of 2. So I think I get just the square root of 2 as my coefficient for part C. So I think hopefully that clears it up how I got that by subbing in K prime is equal to 2K. Okay. How do you derive the equations for springs in series? Okay, so part B then. Springs are in series. I know that the force applied here is the weight mg, which I've just called F, so I don't have too many variables running around. And it's kind of like saying the tension is the same everywhere in the spring, because it's essentially one long spring that you're considering or modeling it as. So F acts on both springs, right? The first spring, when F acts, you get its spring constant K followed by its extension x1, so F equals Kx1. Similarly, this F also acts on the second spring. The amount that acting is the same, F and F, because F is same in every part of the string. It's not like half of F will act in the first go, half of F will act in the second. That's only the case of parallel, where they're two different springs. For one spring, you're going to have the same F. So F equals kx1, F equals kx2. And obviously, just by looking at it, you know that overall extension is x1 plus x2, and they're both equal. So I get an overall extension of 2f over k by adding them up. So you can sub that in. And yeah, so that's just how I got the equations of motion. So my first bit here, these are the equations of motion for both the systems. Oh, thing I meant to say. Yeah. Apologies, I missed the wrong 5 minutes. What was the answer to part B and C? So yeah, these are the, sorry, I've got like so many annotations now that I'll just highlight. These are the final answers. For part B and C, in my further maths, we have used F equals lambda x over L for Hooke's law. Just wondering what the difference. Yeah, I remember this. In further mechanics or something, they use a different formula. It's just a different way of connoting what they're trying to say. Lambda over L is just how you define spring constant, and I'm assuming L is like the length of the spring that you're considering. So because we know that the units of K, if you look at the units, it might help you understand what's going on. So the units of K is Newton per meter. So if you do KL, lambda equals KL, you get units of Newton. So it's just another way of saying what the spring constant is by not defining the spring constant because it's defined per unit length, but just generally giving a value, lambda, and then you can divide it by the length of the spring to get the spring constant, but they're exactly the same. And you could have used that as well. I think it just simplifies to use Hooke's law because it's just GCSE. I have seen 6 markers on pad. Do we get just 6 accuracy marks?
Oh, don't worry, Aria. I'm doing the questions about the Pat tech behind the
Lovely.
scenes. You can just stick to your questions.
So
if there's anything about calculators or anything like that, just ignore them. I'm answering those in the chat.
Sounds good. So are there any other questions about question 3 or 4? I think
you answered the question about further maths, didn't you?
Yeah.
Yeah, I think you're okay then.
Okay, lovely.
And everyone, thank you. I will turn on my camera as well. Aria, thank you so much. That was really beautifully presented. I think everyone will agree. We've all had a chance to ask all of our questions as well. And behind the scenes, guys, please do keep the questions coming. I am gradually typing up answers to everything that comes through to me as well. Amazing. Thank you so much, Aria. Aggie, I believe that brings us to you.
Yeah,
we have
hello.
Raced through these today, Aggie, so you can take your time.
Yeah, I'm not used to this.
No, it makes a change, doesn't it? Usually it takes us a lot longer.
Yeah, so I'll share my iPad screen because I've never logged into Zoom. Oh, there you go. Okay, so that should, in theory, you should be able to see my good notes, right? Oh, I don't need to see myself. There we go. Can someone not see the screen? I guess is the better answer. Well, okay, good. It seems that people can. Anyway, so I'll go through the last 2 questions. Let me just, there we go. I've got the Q&A open as well. So the first question states that I walk down a long street at 1 meter per second. So I'll just put that here because I forgot to put the units. During this time, I count the number of trams that pass me by, knowing that they follow a regular timetable in both directions. I'm initially surprised to note that only 15 trams overtake me, whereas 20 pass me head on. So I kind of drew this diagram before I started presenting because drawing diagrams is very important in all of these questions because you always get marks for diagrams. So the way that you would solve this question, and there's different ways to think about it, but I found that the easiest way to explain this would be to consider what everything looks like in this sort of, in this sort of road frame, right? So what happens here is we've got the trams which pass me at some velocity v. We're going to label the velocity of the trams as v. We've got some trams which then pass me going the opposite way, again at velocity v, and I'm walking at 1 meter per second. So now if I go into my frame, right? So I'm walking like this, and now I'm going to go into my frame. So in my frame, my velocity is equal to 0, right? Because I'm just in my frame. But now I need to correct the velocities of what the trams are. in this frame. So the trams which move past me, well, they're going to have a smaller velocity, right? Because before they had this velocity v, but now I need to subtract 1. Think about this, right? If I was moving like this and the tram was moving like this, if I started moving in my frame, the tram would appear slower, right? And the tram's moving in the opposite direction. Well, now, because I'm in this frame, I'm traveling towards them, right? Because they're meeting like this, which means this velocity is going to increase. So you get v plus 1. I guess an easier way to explain this is the fact that I always subtract the velocity into which frame I'm going in. So here it's -1, but here my velocity is technically minus v, right? Because it's v in the left-hand side, but going right, it's minus v. So when I do minus v minus 1, I get minus v minus 1. So when I transform that to be in the left direction, I get v plus 1. So that's kind of essentially, it's a bit of a difficult question to get your head around. Kind of, go in between these frames because it's not really a GCSE thing, but it sort of does make physical sense, right? That the trams going past me are going to travel slower when I go into my frame, and the trams going on the opposite direction, they're going to be traveling faster. So we've got this diagram, right? Another thing that the question tells us is that the trams follow a regular timetable, which means that I can assume that the distance between all of these trams passing me is going to be constant, right? If I just consider myself standing here, I can just think of the trams as like one huge line separated by some wavelength. So now we've got a speed, we've got a wavelength, and we've got a frequency. So this question is practically begging for us to use this wave equation. And I know it might seem a bit weird to use a wave equation for something like this because there's no waves involved. But at the end of the day, the wave equation just relates some sort of periodic phenomenon to its frequency and its speed. That's what waves are, right? So we can just think of these trams as a wave. So let me just write what this formula is. This formula would be v is equal to, well, the velocity. This doesn't necessarily have to be, so I'll just use a different v. So the velocity is equal to the wavelength times the frequency. So if I sort of write all of this here, I can see that in this direction where I've got 15 trams going past me, I know that v minus 1 is going to be equal to, well, the frequency, well, the wavelength times 15, right? And for the opposite direction, I'm going to have v plus 1 is equal to the wavelength times 20. So we want to find v. We don't care what the wavelength is, it's just a constant. So what I can do is, let me just label these equations. I can do equation 2 divided by equation 1, and I get that v plus 1 over v minus 1 is equal to 20 over 15. And this, now we've got an equation which is very easy to solve. If you just solve this, you get that the velocity of the trams is equal to 7. And remember your units, because you don't want to lose marks, it's meters per second. That's because my initial velocity was given in meters per second, so this is going to be in meters per second. So one of the questions, why can't we just call the frequencies 15 and 20? Because frequency is the number of times that something happens in a time interval, right? And here, the frequency of the trams passing me, so I walk down the street for an hour, right? It's going to be 20 trams per hour. That's my frequency, right? That's why I put my frequency to be 20 and 15, because again, I can have any units I want, right? Again, it's just frequency is just something happening, and like, and if how many times an event happens in a specific period of time, right? So hopefully that answers that question. Can you explain how you got v plus 1 and v minus 1? So that's kind of what I was aiming at the start of the session, at the start of this question to explain. It's because when I move into my frame here, right, in the frame where I'm stationary, I want to find what velocity I would measure of these trams, right? So think about it, when you're sitting on a train and you see the train depart from the platform, right? If you think about it, it could actually just be the platform that's moving, right? And you could be the one that's stationary in the train. I know that's kind of crazy to think about, but you know, it's all relative, right? So what I want to do is I want to be in this frame, and if I am in this frame, right, and I am the one that's stationary, I want to find what velocity of the trams I will measure, right? And it does make sense that I should subtract the velocity, right? Because here, my velocity in this frame is 1 meters per second, right? When I go into the frame in which I'm stationary, it's 0. So clearly I've subtracted 1. And then I have to do everything else. I have to do the same thing to all the other speeds. So this one, I get v minus 1, because v minus 1 is v minus 1. But on here, because I'm going in the left direction, right? which is technically a negative velocity because I'm going to define my positive direction and my negative direction here, as you should always do, because velocity is a vector. Now here I'm going to have minus v minus 1. That's why I get, so in theory this should have minus v minus 1 going right, but if I want to translate that into going left, it's v plus 1, right? Because remember, velocity is speed in a given direction. So that's that question. Why did you divide them? So I divide them because of the fact that I've got a lambda here and a lambda here, and I don't care what this lambda is, right? And the easiest way to get rid of them is to divide equation 1 by equation 2. Would the frequency not have to be in hertz if using meters a second as unit for velocity? The thing is, I never specified what my wavelength is measured in, right? My wavelength could be measured as something else. And okay, maybe you're right. Maybe I should, if I was being strict, right? If I wanted my frequency to not be per hour, right? To be per second, right? Then you're right. I should technically have 15 times some constant, I don't know, like 60, right? So, I mean, it would be, instead of, 20 trams per second, it would be, I should divide it by 60, right? So if I was being precise and I wanted to have all the units correct, I'd have to divide this by 60, divide this by 60. But as you can see, I do the same thing on both sides. So when I divide, they just cancels out. I mean, if you wanted to be if you wanted to be really rigorous, that's what you would do. But at the end of the day, the whole point is the fact that my velocities are proportional to the frequency. So whatever proportionality constant it is, I can just divide it out and it's all going to be good again. So how is the answer 7 again? It's 7 because if you solve this equation, you get 15v plus 1 is equal to 20v minus 1. So 15v plus 15 is equal to 20v minus 20. So you get that 5v is equal to 35. So v is equal to 7. How do you get from v plus 1 over v minus 1 equaling 4 over 3 to v equal, yeah, I've explained that one already because that's the same as the question above. Why do you use the velocity in your frame of reference when you're using the frequency and wavelength outside of your frame of reference? i.e. the trams may not pass you at a constant frequency as you move in, so why do you use the velocities relative to you? The trams will still pass me at a constant frequency moving past, the frequency of them passing me is still going to be constant because think about this analogy, right? Considering the trams as like one big long string with some sort of wavelength separation. If I just move into my frame, this is still going to hold. It's just going to be moving at a different velocity. I mean, if you're interested, I mean, okay, this is completely off syllabus, but if you're interested, if you look at like what happens when the trams travel at the speed of light, then you would be correct. You would have to account for that. But again, if you want to look into that, I would leave that. I'll leave that to you. So I got 15 and 20 because they were the frequencies, and I put them into my formula. Don't you have to include the distance that you walk between the trams passing you? So I don't need to do this because I'm in this frame where I'm stationary. There's another way that you can do this question, which I don't have time to explain now. Maybe if I have time at the end, I'll explain it. But if you wanted to, and you wanted to consider the whole situation in the frame in which you move in, you would have to consider that. You would have to, that's why I think this method is the easiest one, but maybe it's not the easiest one for you. So yeah, so that's this question. I'll move on to the next question, and if I have time, because it doesn't seem to be any more chats and any more questions in the Q&A, but if I have time at the end and more questions come up, I'll answer them.
I've been trying to mark them as answer live and then done as you've gone through your explanation, so I think we're going.
Yes, thank you so much.
If there are any additional questions for Aggie, can you pop them through with the question number, and then we'll come to them as we do?
Yeah, okay, so I'll move on to the next question and then I'll go back to the other questions just because I want to make sure that everything is finished on time.
Great, thank you. So if you've got any questions at the moment, don't worry. If they don't get answered, we'll come back to them.
So the last question, it should be a bit easier, states that Haley and Rob offer to paint the outside of our house. Haley claims she can do the job in 2 days, working continuously. I mean, that doesn't seem very ethical to me. Rob says you complete the job in 3 days. If they are both hired to work together, how long should it take? Let's just consider what happens in a day, right? So in 1 day, let's see how much of the house would Hallie paint, right? So Hallie takes 2 days to paint the whole house. So in 1 day, she would paint half the house, right? Because again, each day she does half the house. So in 2 days, she's going to do the half. She's going to do the full house. So she does half a house. Now let's look at Rob. And Rob takes 3 days to paint the full house, right? Which means that he would take, in 1 day, he would paint a third of the house, right? So if they work together, they would, so if Hallie and Rob work together, they, both put in an honest day of work, right? They would paint a half plus 1/3, which is equal to 5/6 parts of the house, right? Because Hallie would be busy away painting her half and Rob would paint his 1/3, right? So together, you just have to add the fractions, right? So it's going to be 5/6. So that's how long it takes them to paint. That's how much they're going to paint in a day, right? And now I want to know how long it's going to take them to paint the house, right? So if 1 day is equal to 5/6 of the house, then you can just easily multiply both sides of the equation by 6/5, and I get that 6/5 days is equal to 1 house. Hence, the answer to this question is 6/5 days. So, I mean, you can write that as 1.2. And that it's a bit more of a faster question. So if anyone has any questions about that, then I kind of put it in the chat. If not, I'll let you guys kind of put the questions about that in the chat, and I'll just answer the 2 remaining ones.
That's great. We also had a comment which I have dismissed, but somebody said they were really struggling with that problem and turning it into a waves problem is inspired. So that has obviously gone really well for you. Great work, Aggie. Thank you.
Well, I mean, I didn't write this solution, right? I mean, at the end of the day, I was not the one who came up with this. So I can't take the compliment. It was probably some people that wrote these solutions ages ago. But sometimes it's kind of useful applying things in physics in a completely different, like looking at them in a completely different view. But I guess that's what the PAT is meant to test.
Yeah,
anyways,
absolutely.
So no one asked questions about this one, so I'll just go back to the one before. Someone said I got 7 meters per second just by dividing 60 by 20, then divided by 60 by 15, then adding 2 answers together. I mean, that's a way that you can get 7, but without seeing your discussion of the result in full, I can't really say if that's right or wrong. I mean, it gives you the right answer, but getting the right answer is not always correct. So I kind of would, if I was marking this for real, I would kind of need a bit more discussion. Like, why are you dividing 60 by 20? Why is 60 a significant number? I mean, yeah, okay, it's an hour, but yeah, I can't kind of see why you got the 7 meters per second here. Maybe it was a coincidence. And then I did something pretty to this and it worked out and I'm not, oh, okay. I set v plus 1 is equal to 180, v minus 1 is equal to 40, so 2v is equal to 420, v is equal to 210, and then with 2, so again, this is sort of, like, I can sort of see, the thing is, there's a lot of ways to get to the right answer incorrectly, and I do sort of see what you're doing in the solution, but why do you set v plus 1 to 180, right? You kind of do need to explain the significance of why you're multiplying 60. Well, actually, I don't actually know how you got 180. Yeah, I mean, these numbers do make sense to me because at the end of the day, if you get your v plus 1 and you get your v minus 1 correctly and you guess the proportionality right, you don't even have to guess it, just as long as they're proportional, it doesn't matter what you times them by. So I do think that you did the same thing as I did here, just multiplied them by some factors which were not necessarily justified. But because you divided them by each other, they cancelled out. So yeah, so that was fine. Can you please explain the other way to the Detran question? Do we have time, Kat, or because
do you know what? Let's take a vote. If you would like to see the other alternate solution to the PAT problem, give us a thumbs up. If you don't, you can give actually, we turned off negative reactions. We got lots of thumbs up. What we can do instead is please remember, we are not holding you captive on today's webinar. We have ran through our 6 solutions. I am happily answering questions in the background. If there is anything else you want to ask us tonight, and for example, if you would like to see a more detailed solution to any of our problems, let us know. But if you are happy with what you have got out of tonight, I'll be sharing the recording tomorrow and I'll be sharing details of webinar 3. So I think we absolutely do. You've got loads of thumbs up. Okay. And keep the questions coming. I'm sitting in the background. I am so far up to 56 6 questions answered.
Okay, so I'll quickly go through the alternative way. And this is the alternative way, just a disclaimer, it's not how my brain works. I do prefer it the wave way. But this kind of might clear up some sort of problems for people that
Excellent.
didn't understand the wave
Thank
way.
you so much. And in the background, Liam and Aria, I think you've got 1 or 2 questions coming through with some of the other questions as well.
So let's consider this not thinking about waves, right? 60, there are 60 minutes in an hour, let's work in minutes. It's going to make our life much easier. So there are going to be 15 trams overtaking me and 20 going past me. We established that from the question. So the separation in time of these trams overtaking me is going to be 60, because it's 60 minutes, divided by 50, which is going to be 4 minutes. So it means that every 4 minutes, a tram passes me like this, right? In the opposite direction, I just need to do 60 over 20, and that's equal to 3 minutes, which means that every 3 minutes, a tram is going to pass me going this way, right? So now I have these quantities. Now I need to kind of, decide what I do with them, right? So let's say that all of these trams are separated by a distance d, right? The ones going left and the ones going right. Again, we can do that because they're all on this periodic schedule, right? I mean, I wish that's how trams worked. Anyways, I mean, if you were actually taking the tram, it would probably be like one would pass you and not even stop and pick you up. Anyways, so this is kind of what the situation looks like. But now I need to account, as people pointed out before, now I do need to account for the distance that these trams are going to, for the distance that I'm going to travel in all of these times, right? So the trams which are overtaking me, let me just read this. So the trams which are overtaking me, right? They have to travel in 4 minutes. The distance that they have to travel is going to be. So let me just kind of convert this into seconds because we have the speed in meters per second. So this would be. So it's 4 minutes, and 4 minutes is equal to 60 times 4, so 240 seconds, and this is equal to 180 seconds. Good. So now I need to, let's just consider what happens in 4 minutes, right? So the overtaking trams in 4 minutes, right? They have to travel a distance of d, because that's the separation between the trams, plus the distance that I will travel in this time, right? Which is going to be 240 times 1 meter per second, so that's just 240. The trams which go in the opposite direction, well, they only have to travel d, but now minus the distance which I travel, right? Because I'm walking towards them. So that's going to be 180 times 1 meter per second, which is just 180. So because each tram, they all travel at the same speed, right? It's just 2 identical streams of tram. The difference between these 2 distances is going to be the distance that the tram travels in 1 minute. So we have that d plus 240 minus d minus 180 is equal to 400. Sorry, I probably shouldn't write this down yet. Is equal to what's the word? It's equal to v times 60. Yes, okay, that's correct, right? Because this is all happening in 1 minute, right? And 1 minute is 60 seconds. Good. The reason why it's 1 minute is because here I've got 4 minutes and here I've got 3 minutes, so I need to subtract them. I think that this is a little bit more black magic to me than the wave one. Anyway, so now this is the equation which I have to solve, and quite nicely the d's cancel out, so I get 420 is equal to v times 60, which means that v is equal to 7 meters per second minus 1. So yeah, in my opinion, this is a little bit more kind of black magic because it's kind of hard exactly why, why is taking this away going to be equal to how long the trams travel in 1 minute? It's kind of a bit harder to get your head around, but that should be, that's an alternative way. Let me just see. I think there was one more question. It was a very quick one. So it was question 6. It says that Haley works continuously. Do we assume the same for Rob? Yeah. Like if they like, no point making up some work rate for Rob, right? It's sometimes it's useful. I mean, I guess this doesn't apply to the PAT because the PAT is online, but I guess for your future endeavors is to sort of write at the start of the question what you assume, what you understand from the question. Because obviously different people understand different things, and you just sort of want to make sure that the examiner knows how you interpreted the question. Anyways, I think that's all of the questions. Yeah, I think that's pretty much everything. There is nothing. There's nothing
Amazing.
else.
Thank you so much. Liam, Aggie, and Arya, you are an absolute speed team. We have done this multiple times, and it is never something we finish with 30 minutes to spare. So what I'm going to do is extend my thanks, as everyone else has. I have a few questions that have come through in the Q&A for me. So if anyone has any more general questions, please feel free to pop them through. This feels like a good chance to do our additional Q&A session. As I have already said, you are not obliged to stay. So if you have got all of the information which you need today, I am not going to be offended at seeing those numbers drop. Please do feel free. However, I'm now going to jump in and answer some more questions. So, a few things that I had that were being asked. I've had a few people asking specifically about how long this problem set should take, and I would say especially at the stage that you are at, there is not a specific timeline for us. So we're not saying this should take you 4 hours. What we're looking to help you do is improve your problem solving skills, learn to take different approaches, like when we saw Aggie taking that wave solution method instead of looking at it mechanically. So we're hoping to help you build those skills, and by doing so, increase your speed and fluency. So hopefully that will answer those ones to you. I've also got a sort of group of questions asking about working for the PAT. So specifically, do you need to show you're working, and do you get somewhere to write you're working? So I'll take both of those. It is a multiple choice paper. We do not receive your working. So in terms of needing to show you're working, not in the PAT itself. However, the questions will probably require you to do some working. We do not permit paper and pen or paper and pencil in our test centres. And this is purely because we are sitting the PAT over 2 days over the entire globe. So we try really hard to minimise any chance of our test accidentally being leaked. What this means for you is that we don't want any physical materials that can be removed from the test centre. What we provide you with instead is a booklet of laminated sheets, usually about 10 sheets per booklet, and a really decent quality fine nib pen. So it's not like having a whiteboard and a marker like when you're in primary school or anything like that. It's significantly easier. And that's the compromise that allows you to do your working, to have plenty of sheets to do so, but reduces any risk of the test questions being leaked from us because there is no physical material coming in or out of the test centre. We do know that this concerns people. However, we've tested the whiteboards and the pens. They are good. I would recommend practicing. You can even just get a sheet of paper, pop it inside a plastic wallet and practice with that. You can also request additional booklets if required. So hopefully that will cover that kind of first one. For the working, it's worth bearing in mind that if you are invited to interview, you will then be able to show your working, and being able to show your working is great because we're much more interested in your thought process at that point. Tied alongside that, I've got a bunch of questions about calculators. You are not permitted a physical calculator. This means that we can ensure that everyone has access to exactly the same resources in the test centre. So it's that online calculator. I've shared the link in last week's email to help you to it. Let me pop it into the chat now, where you can access the sample paper and practice using that calculator. And just as I would recommend practicing using the sort of not quite whiteboard, shiny paper, basically, practice using the shiny paper and practice using the calculator as well and get used to those. So that's kind of a fixed group of questions that I had about working, whiteboards and calculators. I'm going to go through and tick off anything that looks like it related to that. Okay, so I think I'm going to be able to dismiss those. Other questions that kind of relate, they are desktop computers that you will be sitting the test on. There is no data booklet, so you will need to memorize any formulae. I will share a recording rather than word solutions, but after the first couple of webinars, I will eventually share solutions. So we're just trying to spread out what we share at the moment. So there will be solutions in the end. I will share the solution webinar tomorrow. So you'll be able to access that. And hopefully that answers a few people who were a little bit late as well. There's not specific homework for next week. Next week we've got Rachel back with us, who was with us for the first webinar. If you were here, you might remember her. If not, next week you get to meet Rachel. She's lovely. She's a teacher who we work really closely with, and she's going to be taking you through a specific optics and waves webinar, so a topic specific one next week. I've also had lots of people asking for resources, and this feels like a good chance to talk about resources that we recommend for the PAT. So first of all, you don't need to purchase anything. Just as it is free to sit the PAT, it is free to come to our Preparing for the PAT webinar. You do not need to purchase any resources to learn for the PAT. But we know lots of you want to do extra practice. So what I recommend is thinking about what the PAT itself entails. What we're looking for is your ability to solve PAT physics and maths questions in new contexts. Therefore, a really good way to help you get ready for the PAT is to practice this. If you are an A-level student, you can branch out and have a look at different exam boards. You will find that they pose similar questions, but in slightly different contexts and maybe a few things that aren't on your syllabus. You can also then branch out, and this now applies whether you're an A-level student or not. Have a look at other countries' exams at the level that you are at. So if you are sitting A-levels, have a look at the Scottish Advanced Higher, have a look at the Irish Leaving Certificate, have a look at the IB Higher Level papers, have a look at the American AP papers. You can find versions of these for free online, and hopefully I've mentioned what everyone here is sitting. I've tried to mention a lot of them. Look at each other's papers. They are the best way to find out how physics at your level is asked in different contexts. It is a great, cheap and easy way to improve your problem solving and to help you prepare for the PAT. So that would be my top tip, is find different syllabuses at your level in different places. And we do recommend that you do as much practice as you can. So get stuck in. At this point, hopefully we all really enjoy problem solving in physics. So those are great places to start. You've also got some resources like the Physics Olympiad, so those are great places to have a look as well. But the more practice, the better. And don't forget to check the syllabus. Would you like me to put the syllabus online? I'm just going to copy and share that. Yeah, I got a lonely thumbs up. There you are. That is the PAT syllabus link. So don't forget to check that. And if there is something on it which you do not know, learn it. And that will probably be the case for almost everyone, because we do have people sitting the PAT from all over the world, sitting different exam boards, different situations. So almost everyone has to do some learning. Right, let me go back to my Q&A list and see if I've managed to answer most of those. Okay, I've got a few questions. Okay, working through. What else have I got? Answered that one. Answered that one. A few people asking, can you take the PAT more than once? You sit the PAT in the year that you are applying, and you can only sit the PAT if you are also submitting an application to Oxford. So we do a match of your UCAS number to your PAT application. So this means you can't sit the PAT a couple of times, try to get a better score and then apply. They have to be done in the same year, but you could do the whole process multiple times if you chose to. Although I think that doesn't sound like the best fun to me. I think most people are probably doing it once. Okay, I've then got a few questions about admissions criteria. So people doing 4 A levels, people doing 3 A levels, people basically asking, what is it that you're actually looking for? So I will say what I say to everyone. We make our offers based upon 3 A levels or their equivalent. So whether that is 3 advanced hires, whether it is your suite of international baccalaureate points, whatever it is we say is our offer, is our offer. That will not change if you are doing a 4th A level. We're not going to reduce that offer for you, for example, but it is specific. We do not change your offer based upon that 4th A level, but the 3 that we choose usually make sense. So for example, I've had somebody send in a question, they're doing maths, further maths, physics, and a language at A level. We are not going to be offering on the language. We're not going to take a rogue status and be like, okay, this time we want an A star in Latin. We don't do that. It's your maths, physics, and further maths that we're going to be interested in there. So hopefully that helps everyone out with those questions as well. We absolutely take into account everything that you send to us. So we will read your personal statement. We will read your teacher reference for sure. We will take into account your PAT score, and we will look at everything else that comes in with us so that we can see, for example, if you've done really well in a school where usually the grades aren't very good. We like to know these things, but there is not a fixed, this PAT score will get you in, these A levels will get you in. We're looking at every application as a whole and as an individual. That's why it takes us so long and we have to get your applications in October, because we're going through them. So hopefully that answers those ones as well. Somebody's asked, are A levels similar in difficulty to Scottish Advanced Hires? Yeah, that's your equivalent level. So that's a nice simple one. I like that. As a general rule, I've had a question here about the colleges in Oxford. So for those of you who are in that process of getting up to speed, you are a member of a college as well as a department in Oxford. So you would all be studying the physics course, but our students here are all from different colleges. Colleges don't make particularly different offers. So it's usually A star and 2 A's. We standardise admissions throughout our department. So in Oxford, what we really want is that when you apply to physics, it doesn't matter where you apply from, either in the world or per school. And it shouldn't matter which college you apply to. So we make sure that we spread out our admissions process so that everyone who is deserving of a place gets a place. So that should answer that one as well. Had a question about deferred entry, and this is where it gets tricky. You've got 2 options. So you can either apply and ask for admission after a gap year. So you'd be putting in your application in October this year, but you'd be asking to start not in 2026, but in October 2027. In that case, you sit your PAT as usual, you put your UCAS form in as usual. Okay? It's then up to your college, and the only difficulty is we then want to know how you're going to stay at that level for your gap year so that when you come in, you are ready to go. And you're also asking, you've got to be good enough when we interview you that not only do you deserve a place that year, you'll definitely deserve a place when we haven't seen the people who we're interviewing the next year. So it can be a bit tricky. Your other option is to apply while you're on the gap year, in which case you will personally need to keep your skills up to date enough so that you can do well in the PAT. So hopefully that answers that one. Now I'm getting to the point of quite specific questions. So I've got someone's already, if my predicted grades don't quite meet the requirements, is it worth deferring a year and applying with final results? I would say this one very much depends on what you can get in the way of your PAT score and your teacher references. So if you think you're going to do a great job on the PAT, and if your teacher references say, actually, we think this kid's going to do really well, we think they're going to do better than their predicted grades, why not give it a shot? Okay. So we don't have fixed, this must be in place, because we look at everything overall. So I would say, give it a shot. You've got nothing to lose. No colleges have a separate or a different entry requirement to anyone else. So nobody can require further maths when as a department, we don't require further maths. So hopefully that will answer that one. Some questions about AP levels and BPHO. I'm not able to know in enough detail exactly which AP course it compares to, I'm afraid. But certainly does no harm to have a look through them and get some practice that way, because again, you're getting that different context. So that's good. BPHO questions are always great practice because again, it's all problem solving technique. We have worked very hard to make sure that the difficulty level across the PAT past papers is exactly the same as the difficulty level this year. And for those of you who I've still got with me, see, I've still got a few of you who are enjoying the questions. One thing you might find interesting is that we do an awful lot of data analysis behind the scenes. So especially as we've brought in this new format of multiple choice over the last 2 years, we have spent an enormous amount of time comparing the questions, comparing the grades, and making sure that the difficulty level is the same. So all of those questions that you've done, those long paper questions that we're going to be working through, are really applicable and are similar difficulty level. Got a few people asking about, will specific things boost your application? And I'll say there is no one specific thing that will boost your application. We don't have a checklist where we're like, oh, they've got that though, and they've got that. It is a look at the application as a whole, but it will make no difference. So anything that makes you a better physicist and that you can tell us about, that makes you feel like a better physicist and makes you better prepared, absolutely go for it. But we don't have a specific, that gets you an extra check in our boxes, simply because everyone has different opportunities available to them. So we can't give specific boosts for opportunities that aren't universally available. Instead, what we want to know is that you've made the most of the opportunities available to you. So if you've had a really cool opportunity to do something in physics and it's made you a great physicist, tell us about it. We want to know, but we don't have boosts or drops in that sense. So hopefully that helps. Somebody's asked about being made an offer if they've got chemistry, physics, maths, and further maths. With those 4, you would be offered on maths, physics, and further maths. You would not be given an offer on the chemistry for physics. If you're applying for materials science, they would offer you on maths, physics, and chemistry. And if you were applying for engineering, they would get to choose which of those 3 they make you an offer on. I'd say for physics, further maths is probably going to be more useful to you than chemistry if you're thinking in terms of what's going to make you better prepared for the course. Someone's asked a very specific question. Is there ever a case where you get an offer, but you don't make the grades and you still get in? I'd say sometimes, but it's very much dependent on the college. So if you were to be given an offer, which you missed, you are welcome to ask the college if there's any leniency, but they are able to say no. So it's always worth asking, but there's no obligation to give you a place if you don't meet your grade. And sometimes it will be a no, unfortunately. Someone saying they only have maths, physics, and chemistry. That's absolutely fine. All I was saying is if you have physics, maths, chemistry, and further maths, the 3 that we're going to offer on are physics, maths, and further maths. We're not going to offer on the chemistry. But if you're not offering further maths at all, then it's not a problem at all. Sorry if that was a bit confusing. Deadlines for the PAT, I did have them up somewhere in the slide this morning. So registration is open now. You can register as a candidate for the PAT between now the 18th of June and the 19th of September. And then there's a kind of separate window for test booking between the 18th of August and the 26th of September. So your very last registration date is the 19th of September. Last test booking is the 26th of September. So towards the end of September. We got those, and they're all on our website as well. For a materials science course, they'd be looking for maths, physics, and chemistry rather than maths, physics, and further maths. But again, only if that was an option that you offer. That's kind of their preferred 3. So it's all based on what you're able to do. I've got another question. If your school did not offer further maths, tell us in your teacher reference and in your personal statement, and tell us what you're doing to do more maths on your own. Show us that you have that potential. So talk to us if you're doing any extra maths, what you're reading into, and all the lovely things that you are doing anyway. So I think with that, we have reached the end of the Q&A session. I have answered a total of 102 questions from you all with a record 10 minutes to spare. It has been an absolute delight to have all of you with us and those of you who have stayed until the end. Tomorrow I will share the recording of this webinar so that you can watch it as many times as you please, and I will of course share all of these links with you as well, including where to sign up for the PAT and everything else that you need. If there are still any questions, because I'm sure you'll think of something afterwards, please drop me an email and I will be happy to answer those. Consider us your one-stop shop for any PAT related questions between now and admissions all the way in November and December. Thank you so much, everyone. I hope to see you all again next week. Have a lovely week. Bye for now.